So we're just going to do some more practice problems on drawing Lewis structures. So we did the H and O2 last lecture, so now we're just going to do some more. So the first one is to draw the Lewis structure for CO2. So step one is the least electronegative atom goes in the center. So remember, electronegativity increases up and over. So increases up and over. So between carbon and oxygen, the oxygen is more electronegative, which means the carbon is going to go in the middle. So I'm going to put my C and my two O's. Now I need to count my electrons. Carbon is in group 4, oxygen's in group 6, so they're going to have 4 and 6 electrons. So I've got 1 carbon with 4, 2 oxygens at 6, so that's going to give me 16 electrons to work with. Step 3 is to make single bonds. So I make a single bond between everything. Remember, one single bond is 2 electrons. So that's 2 electrons, that's 2 electrons, so I've used 4. So I have to subtract that from how many electrons I had total. This is really important, keeping track of your electrons, because you cannot use more electrons than you have, and you cannot just leave any left over. So you got to use them all. All right, next is to make everybody on the outside complete. So oxygen wants 8, he only has 2. So he needs 6 more. And they're both the same, they both want 6. So that would be 12, and I have 12, so I can do it. So I give this oxygen 6 electrons. So he has 1, 2, 3, 4, 5, 6, 7, 8. And I give this one 6 electrons. So that's a total of 12 electrons that I've just given. All right, next step is to make the central atom happy. He has 4, he wants 8, so he wants 4 more. Do I have 4 to give him? No, if I had them here, I could just put them on. This is why this is so important to keep track of, because then I know I don't have any more to give. So I don't have any more electrons to give. So that means I have to start making double bonds, okay? And so I need to make a double bond. These are the exact same, so I just pick one and I make a double bond. So I'm going to move these electrons here, so those go away, and now it makes a double bond. He still has 8. 1, 2, 3, 4, 5, 6, 7, 8. But now the carbon has 1, 2, 3, 4, 5, 6. So he has only 6 electrons. So now I have to figure out, okay, do I move 2 from here or do I move 2 from here? What do I do now? Because now these 2 oxygens are not the same option. They're not the same choice. So I could choose from A, which would be moving here, and if I did that, then I would have, a triple bond. Or I could move from B, and it would look symmetric. Okay? We're going to stop here, because remember I said we're going to just get all the way to where we have a choice, and then when we have the choice, I'm going to teach you one more step. But I just want to make sure you get these steps first. We'll come back and we'll finish it, I promise. Okay? So that's where we're going to stop here. I will give you a hint. In chemistry, we like symmetry. So I can already tell you without even doing my little check, which is called formal charge, I know this one's going to be favored more because it's symmetric. Okay? But I want to show you why that's the case. Okay? Let's do the next one. SeOF2. So I need to figure out who's going to go in the middle. So I have Se, O, and F, okay? So I need to find everybody on the periodic table. Here's Se, here's O, here's F. So based on my electronegativity, Se is the least electronegative, so he goes in the middle. Se goes in the middle, and then I put the O and the F's just around him, okay? The F's aren't going to go on the O's or anything like that. Remember, the only time we're going to be really doing that is if it's a hydrogen, it goes on the O for an oxyacid. Here, this is just in 2 nonmetals, so they just go on the Se. Now we add it up, so let's go back. Se has 6, O has 6, F has 7, okay? So let's add up our electrons. 1 for my Se, and we said Se was 6. 1O, which is also 6, 2 Fs, which we said was 7. So that's going to give me a total of 26 electrons. Remember, it's neutral, so I don't have to add anything, and it's an even number, so I feel good about it. Now I make single bonds. So I attach everything together. That's 2 electrons, 2 electrons, 2 electrons, so that's 6. So remember, I got to keep my math going. So 26 minus 6, I have 20 left. All right? Now I want to make everybody on the outside happy. Oxygen wants 8. He only has 2, so that means he needs 6 more. Fluorine wants 8. He only has 2, so that means he needs 6 more. Same here. So they all want 6 more electrons. That would be 6, 12, 18. I have 20, so I can do that. So I go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I've used 18, so I have 2 electrons left. All right, next, Se. Se wants 8. He's got 1, 2, 3, 4, 5, 6. He only has 6. He wants 2 more. Do I have 2? In this case, I do. So I just put them on there. So I put those 2 electrons on the Se. I've used all my electrons. All my electrons are used. Because I got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So all the electrons are used, and everybody has 8, because he has 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, and then 2, 4, 6, and 8. So he's good to go. So he is finished. All right, to break up the videos, we'll do NO2 minus on the next video.